Hi everyone, my name is Lorenzo Boaro and I'm here with Claudia, and today we will speak you about static analysis and certificate pinning. So I'll let Claudia speak. Thank you.
Every application must decide sooner or later to check the security aspect of its code implementation. Unfortunately, this step is sometimes underestimated. One reason is the simplicity of the final product can mislead about the problem can emerge. Or the problem is the lack of time, or the need to support legacy code that prevents a complete rewrite in case of error. By ignoring security during the development phases, you are bringing a product into production and you cannot be sure about that nobody can exploit your code, causing damages to your company and your customers. Why you should check the security of your code? The first code to be achieved is to verify all the application code, both on new functionality and the old ones. The code must be verified automatically, with the same check every time, in order to avoid the human error that can skip a check for a simple distraction. To do this, there are two types of analysis can be completed. The first one is the stacked one that allows you to verify the code without having to execute it, removing for the analysis the instability of the environment in which the application performs. The analysis can also be carried out in the early stage of the application development and allow you to immediately intercept security problems. The dynamic one allows you to verify the application in an environment that resembles the production as much as possible, simulating the behavior of a real user. In this way, it's also possible to check the integration with external services. But there is no right time to perform the security check. The best practice is that the sooner the checks are carried out, the sooner it's possible to intercept problems and solve them. This allows you to perform a check on the core feature and prevent them from presenting a security problem that has a significant impact functional. The automatic analyses are very fast and allow you to perform a daily check, even on an application whose code base is growing very rapidly. The report generated must be analyzed not only to resolve the reported critical issues, but also to improve the style of the produced code by the whole team and to avoid that the same error are repeated several times. There are various tools available on the market that allow you to analyze the code and its security vulnerabilities. There are three main players that stand out for their feature dedicated to the mobile application. CodeChain allows you to perform a behavioral analysis of the code to find vulnerabilities during an interaction with your application. It also allows prioritization of report based on the writing style of each developer. It verifies when new vulnerabilities appear with the introduction of a new feature. The second one is SonarCube. It's a platform that allows you to easily integrate into DevOps chains with a continuous analysis of the vulnerabilities. It also carries out a broad spectrum analysis, for example, checking also duplicate code and the existence of unit tests. The tools also verify the evolution of the code base and their existence of new vulnerabilities when the new functionalities is introduced in the code base. Veracode is the last one, is a cloud service that allows you to perform both static and dynamic analysis. It easily analyzes mobile application as well as other software. In Sisal, we have chosen to use SonarCube, and we want to show you the reason for this choice. SonarCube process is very simple. It's divided in three main phases. The first one is application build, in order to have all the classes compiled in which to perform the analysis. The second one is the scan of the application code, indicating the folder and the language used to allow SonarCube to perform a complete scan. The last one is the analysis of the results, prioritizing the most relevant reports and using them with the filter made available by SonarCube to plan the resolution. The first step is very simple. For the other two, we have some tips for you. For example, SonarCube requires a simple configuration file in order to understand what type of code it must analyze and where it must analyze it. If you need to analyze several applications, the management of the file can become critical because it will be duplicated in every development branch. An update of the file will be almost impossible to do. We suggest the use of a standard template with base definition that is compiled at runtime before starting the scan. The template can be customized by indicating modules to be analyzed, a specific language for each modules. Inside the DevOps chains, you can compile the template with the simple regex. Our solution involves using Jenkins as a tool to coordinate the DevOps implementation. Jenkins allows you to connect to your repository to download the source code and automatically run the build phases. Jenkins provided a dedicated plugin to integrate analysis with SonarCube. You must define the endpoint of your SonarCube instance and the access token to allow the result to be published. SonarCube analysis may take a few minutes based on your code base. This is why a dedicated step is provided to await the conclusion of the analysis and to recover the result. SonarCube verifies whenever a project passes or not the security check, based on a minimal threshold error, defined as quality gate, which indicates which issues must be resolved before entering production. The analysis for our intention must be shared with the whole development team in order to evaluate the quality of the code produced. We have chosen to integrate with Slack through a simple notification, which indicates the main violation found and the link to the complete analysis. It's impossible to enrich the information using a REST API offered by SonarCube. In our case, we decided to use a dedicated API, the project status, which allows us to identify all the errors that cause the quality gate to fail. But how to analyze the different language with SonarCube? Also in this case, we have the possibility of using a dedicated plugin, which offers product code coverage in the mobile environment. The first two standard plugins are dedicated to Java and Kotlin. They are supported by the SonarCube team and updated very frequently. As for Sweep, there is a plugin supported by SonarCube, but it requires a dedicated license, and updates are not very frequent, as in the case of Java and Kotlin. If you wanted to do a more specific analysis, you have the possibility to choose plugins dedicated to Android and iOS. They are open source and allow you this integration directly in SonarCube. We are not considering them because the definition of the rules are not updated very frequently. In the mobile environment, when the operating system update is made very often, we believe that it is essential to have the latest definition of the security and the writing style rules available. Each development team now needs to think about the security needs. Do we have frequent updates and therefore we can take advantage of the last security rule definition? Is the team very large? It is better to plan remediation based on the local characteristic of each developer. Is there any legacy code which must be analyzed with special plugin? Having defined your needs, you can choose between standard plugins, which are easier to install and have support to all available languages, and custom plugins, which make the analysis more flexible and adapt to the most particular needs. We have chosen in Sisal a mixed solution, using the standard plugins as much as possible and resorting to the custom plugin only if a definition or the rules are not updated frequently. Our custom plugins are dedicated to define specific rules for Android and iOS. Both platforms have a public page where they define the rules of Swift lint and Android lint. This page can be easily analyzed automatically by Jenkins with some regex. In this case, you can extract all the list of all the rules at any time. Jenkins allows you to define a recurring job, which can be scheduled every week, for example, to check if the definition of rule is updated. The new list of rules to be processed by SonarCube must be translated in XML file. Each node of the file is a rule for SonarCube. Each rule must have some standard attributes which makes it unique, and some specific attributes that will be used for creating the analysis report. The same flow can be applied to create custom rules for more specific control. The XML file can be very flexible, allowing you to add details even to the standard rules in order to enrich the final report. Now that we have a list of well-defined rules for SonarCube, we need to release the plugin to allow all the analysis to use it. The release consists in 3 phases: creating via Maven the jar containing the rules and specification of the plugin, adding the jar file to the plugin folder of SonarCube instance, removing the old jar file, if it exists, and restarting SonarCube to load all the new rules. As a final suggestion, if you want to make automatic the planning of SonarCube issue, you can integrate the entire process with your ticketing system. In our case, we use Jira to address all the developments. After each daily analysis through Jenkins, we verify the new issues created by SonarCube. The final report is formatted to be readable by Jira. For example, we explicitly indicate the impacted component and the identified violation. To make life easier for our developers, we also add a direct link to reporting on SonarCube, so they can check for suggestions on how to solve them. Now you have an application that has been secured, tested, and you think you are ready to go to production. But sorry, guys, it's not the same, because now Lorenzo will talk about a very important step.
Okay, so the first question I will ask you is, how many of you use certificate pinning in your app? And maybe knows about TLS, SSL? Okay. So today I'm going to present you a very challenging argument that is certificate pinning. But before understanding certificate pinning, you should grasp how the concept about TLS, so transport layer security. As a side note, in this presentation, I will use TLS and SSL, Secure Sockets Layer, as synonyms. Secure Sockets Layer is the vulnerable ancestor of TLS, and hence no more used. So just a brief recap. Maybe in your studies or in your daily work, you have used cryptographic frameworks, system technologies, and then you can classify them into 2 main fields: symmetric cryptography or asymmetric cryptography, or public key cryptography. So the first one can be used encrypting or decrypting messages using a shared key, while the other one using a private and a public key. For example, I have a server, and the server gives back to the client a public key. This public key can be used to encrypt a message that the server can decrypt. So TLS, Transport Layer Security, is a protocol. The main goal of this protocol is to provide to having a secure network connection between two entities. The first one can be a client, a mobile application in this case, or a server, and a server. And then TLS allows you to transmit data over network without exposing the data to untrusted third parties. The connection is composed by three main parts. We have initiation, verification, and exchange. Let's see initiation. So the client starts a connection with the server. Along with the first message, the client also sends to the server the TLS it supports, 1.2, 1.3, and so on, and also the cipher suites. So a set of algorithms that can be used for encryption, decryption, and also to generate the keys. The server responds back to the client, giving to him the selected certificate, the selected cipher suite, and also one or more digital certificates. The client then verifies through a validation step, we will see it later, if the certificates are valid. If the validation succeeds, verification phase begins. So this is where this is the phase where public key cryptography is involved. So the client generates a pre-master secret key, and this pre-master secret key is encrypted with the public key of the server. The server receives this pre-master secret key and decrypts it with its private key. Okay. Now the client and the server have a pre-master secret key, and with the same steps they can generate a master secret key. And this master secret key is the one that used to perform symmetric cryptography. So this secret key, this share key, is used to encrypt and decrypt the communication between the two parties. Okay, so we have seen that the server sends back to the client one or more digital certificate. What is a digital certificate? So a digital certificate is a file. It contains data. You can think of a digital certificate as a sort of passport or card identity, okay? The certificate can be issued by a certificate authority or can be self-signed. What's the difference? In the first case, so if the certificate is issued by a certificate authority, the certificate authority must validate the identity of the certificate holder. While in the self-signed case, the subject, so we requested the certificate, and the issuer who provide the certificate are the same identity. Digital certificate can have different encodings. These are the encodings we can have. So we have a privacy-enhanced mail, that is a base 64 encoding. We have distinguish encoding rules, that is a binary encoding, and then public key cryptography standards. This is another binary encoding. Those encodings can have different extensions. So you can save in your file system a certificate, and this certificate can have a different extension. For example, in the distinguish encoding rules, you can have a CER extension, a DER extension, or CRT extension. Okay. How can I request a digital certificate? So the main goal here is to request a certificate signing request. I think if you are an iOS developer or maybe an Android developer, you can go in your Apple Keychain application, and then you can say you can request a certificate from a digital certificate authority, from a certificate authority. This is the step I can do in order to request a certificate. At the end of the request, I will have a certificate that is verified by a certificate authority. In the case of iOS application, the certificate authority in this case is an intermediate certificate authority, and this is Apple. A certificate is based on X509 standard, and it have different fields. We can see them here in this slide, and valid from, valid to, or the digital signature can be used in order to verify the authenticity of the certificate. Okay, the two important steps an important step of the initiation phase of the TLS is the validation of the certificate, okay? I can validate a certificate using the valid to and valid from fields, but I can also use the digital signature. The digital signature is a signature, as the name implies, that is attached to the certificate and sent back to the client. So, how does it work? So when I have my digital certificate, I extract the data, and then these data are passed through an hashing function. I generate an hash. This hash is then encrypted with the private key of the server, the issuer in this case. So the certificate authority that gives me the certificate. And then this signature is attached to the certificate itself. When you get a certificate from a CA, that certificate is part of a chain of certificates. As I said before, during a certificate validation, the first thing I do is to verify that the date of the evaluation falls in the range of valid to, valid from. So valid from, valid to. And also, it's also validated the signature by finding the public key of the next issuing CA or intermediate CA. The process continues until the root certificate is found. Usually, the root certificate, like Baltimore or I don't know, another one, is embedded within your mobile application. For example, in iOS, the iOS keep a well-known list of CA certificate authorities. But if you open Firefox or Chrome, you can find those certificates into them. When you validate a digital certificate, there is the digital signature validation, and the digital signature validation is performed on the other way of creating the digital signature. So I have the certificate, I have my digital signature, I extract from the certificate the data, okay? I pass the data through an hashing function. This hashing function creates for me an hash. Then I have the digital signature. I decrypt it with the public key of the certificate authority, and then I have an hash. I compare these two hashes. If they are the same, I mean the certificate is valid. So now that you have grasped all the concept about TLS, I will speak to you briefly about certificate pinning, and also how to perform pinning, for example, in iOS. What is certificate pinning? So for every operative system, the networking stack is responsible for setting and maintaining TLS sessions. But an attacker can generate a self-signed certificate or evenly create a fake root certificate and perform a man-in-the-middle attack. So restricting the set of certificates through pinning prevents the attackers from analyzing the way your application, your client, communicates with your server. And this is very important in order to protect the data of your customers. What are the main two types of certificate pinning? We can have the pinning of the certificate, but also we can have the pinning of the subject public key info. So in the first case, we have the certificate from the server, and then we embed it into our application, iOS and Android application. In the second case, instead, we create an hash of the subject public key info. The subject public key info, as if I go back to the slides I present you before, is the couple public key, the algorithm I use in order to create the digital signature. I have this subject public key info. I pass to the subject public key info data to an hashing function. I have an hash. I hard-code that hash into my application. Maybe I can find something better. But anyway. Now you have all the concept about certificate pinning. Let's see, for example, how to do certificate pinning in iOS. First of all, you need to grab the certificate. You need to grab the certificate from your server. And in order to grab the certificate from your server, you can use a script like that with the OpenSSL command. And this command does simply the following. So it connects to your server, myserver.com, to the specific port, and then using an encoding of DER, it saves the file to your file system with a DER extension. Okay. Now we have the certificate. What we can do with the certificate? We can do pinning. And in iOS, maybe you are using your session, you are using Alamo Fire, or maybe you can use TrustKit. And we will see them now. URL session, NS URL session previously. First of all, you need to create a URL session, but you cannot create a URL session with the singleton pattern, but you need to create the URL session using an initializer, where you pass the delegate, okay? So the delegate is very important because it allows you then to keep track of the challenges the servers gives back to you. And then there is a specific delegate that is called your session did receive challenge. And the challenge is an object that internally contains the certificate that the server in the initiation phase of the TLS gives back to you. Now you have this certificate retrieved from the server. You have your certificate that you can bundle within your application. You match them. If those certificates are the same, you can continue the challenge. Otherwise, you can do whatever you want. For example, you can skip or cancel the challenge and then interrupt the communication. This is very simple. And another way to do it is, for example, to use Alamo Fire. Maybe in your iOS application you use Alamo Fire a lot, and Alamo Fire from version 5 has been improved, and you can use a PIN certificate trust evaluator. This PIN certificate trust evaluator accepts a list of certificates. And then you can pass this trust evaluator to a server trust manager. And then the server trust manager does the thing for you. Now, when you do a request through Alamo Fire maybe gives back to you an error. You can cast that error and then to an Alamo Fire error, and then you can verify there if you have a trust evaluation error or not. Again, this is very simple. Another way to do it is to use TrustKit. TrustKit, I think, is very powerful because, first of all, uses, I don't know if it's very powerful or not, but anyway, it's very cool, uses Swizzling, method Swizzling, in order to do the certificate pinning for you. But respect to the other two, so your session and Alamo Fire performs pinning on the subject public key info. What does it mean? That you have a certificate, TrustKit provides you a script, you pass the certificate into this script, and then it generates an hash. And then you can have this hash, and then you can put on your application. Now you can configure the certificate pinning using a trust kit configuration. Also, trust kit gives you a callback, like in the other two, and this is a pinning validation callback, and then in this callback you can verify if you want to continue the connection or not. So again, very simple. Another aspect that have trust kit is that you can, for example, connect trust kit to a backend service that allows you to analyze if the client has a pinning failure or not. This is very important because maybe you want to analyze the traffic and then you want to have a full control of all your applications. I will end with some side notes about this presentation, about certificate pinning in general. First of all, when you do certificate pinning, you need to test the implementation of your certificate pinner. And you have different tools in order to test it. We have MTM proxy, Charles proxy, or Burp Suite. The first one is open source and for free. The other two are not for free, but they are also very powerful. And if you prefer a user interface, you can use them. The other thing is, it's really important to understand what is certificate pinning. And also, it's really important to understand how TLS work. Why? Because you can create you can have an application that cannot work anymore. And in order to prevent that, you always need to provide fallback mechanism. With the fallback mechanism I need, maybe you want to have a fallback certificate on your server and on your application, because maybe your certificate in your application sooner or later will expire. And also, you could have a mechanism to enabling and disabling certificate pinning on demand. Maybe you can host some configuration somewhere for your application, and then you can switch on off the certificate pinning, because if the certificate pinning doesn't work anymore, your customer will not able to use the application. So here I put some references about certificate pinning. If you want to see certificate pinning, you have a lot of resources out of there. You have, for example, a link in Preventing Man in the Middle Attack in iOS with SSL pinning. It's by me, but it goes through the certificate pinning, and then you can verify it with the Charles proxy as well. Another aspect I will add is that, okay, this is I talk about iOS, but you can have certificate pinning also in Android. With the version of NuGet in Android, you can have network security XML files, and then you can put the hashes of subject public info there. But TrustKit works also with Android, so it's very cool to see it in action. And yeah, so that's it. Thank you for your attention.